Okay, mister. So today we're going to be doing a physics experiment, okay?
Mhm.
And we have to set it up, okay? So this lab is about projectile motion.
Huh?
Can you say that with me? Projectile motion.
Projectile motion.
Yeah, that's like when you shoot something out.
Yeah, like the video we watched where the guy drowned.
Yeah, so I was going to bring up that video. We watched a video where it was talking about a guy who jumps off a cliff but he doesn't jump up or down, he just runs straight off the cliff, okay? Because when we first talk about projectiles, things flying through the air and how they move, we first talk about it in a more simple way where it starts off only moving horizontally,
Yeah.
okay? Just straight, okay? That makes it easier to figure out how far it's going to go, how long it takes to get there,
Mhm.
and so on and so forth.
Paper.
Okay, so here, carbon paper is this stuff right here. This is black carbon paper. Usually you use it for copying stuff down. When you write on a paper, you put this underneath that paper, and then you put another paper underneath it, and it will copy it. It's called carbon copy because there's carbon ink underneath it. Or I don't know exactly how you say it, but it's basically it's a paper with ink on it, and when you push on it, it will make a similar the same mark on the paper underneath. Okay, it's a way to copy stuff. Okay, by hand. Please don't do that.
Okay.
Okay, now this is what we're setting up right here. So this is where we're gonna put a marble at the top, and we're gonna launch it. And you see how it's flat here?
Yeah.
Are you bored?
No, I just can.
Okay, wake up. All right, now don't get bored already. The exciting part is coming. Okay, so this part is flat. You see that?
Yeah.
So that means when the ball comes from here to here, it's going to pick up speed because it's going down. Okay? Now, if we drop the ball from the same spot up here every time, it'll be the same speed pretty much every single time. Okay? But when it hits this part of the ramp, it's going to only be moving horizontally, sideways, okay, along the x-axis. Okay, we're going to call it x-axis, all right? That means horizontal.
Yeah, but then when it's here, you have to dig it a little bit deeper because it might go off the side.
Well, we have this guy here.
Yeah. Oh,
It's a piece of aluminum U-channel.
Oh, yeah. I know that
Okay,
one.
and it's a good size for putting a marble in, so it will not fall off the sides.
Oh,
Okay, but this is completely flat. Hopefully not bent at all. But we're gonna bend it. We're gonna bend it like this one.
Let's go. Time to bend it.
Okay.
With our muscles or with the machine?
We're gonna use a clamp and maybe our muscles and maybe some pliers and maybe a little bit of a hammer. I'm not sure yet, but we need to do it carefully because we need to make sure that this part is flat. Okay, and you see they did it here. They just bent one part of it pretty much, but we don't want it to be too sharp of a bend, or otherwise it's going to hit here and bounce. We don't want it to bounce. We want it to just roll through. Okay? So we got to do it carefully. Now, if you see here, what's going to happen is it's going to come out, and as long as this is at the same spot, we haven't moved it left or right or up or down, X or Y, okay, then it will land pretty much in the same spot every time. Not exactly the same spot, but it's going to land pretty close to the same spot every time. Okay?
So let's get building.
It might move by a little bit.
Like
okay?
an inch or a millimeter?
We're going to find out exactly how much, but it should land almost in the same spot every time, as long as you don't move this and as long as you launch it from the same spot. Okay? But what we're going to learn how to do, okay, is it says here in our instructions that first we're going to figure out exactly how fast our ball is moving. Okay, now if you remember in that example from the guy jumping off the cliff, please stop.
Okay.
We assumed that the guy was running at 5 meters per second. Okay, now mommy said that you don't know. Mommy said that you have a little bit of you don't really fully understand the units, right?
Yeah.
Okay, well, people measure things in different ways.
Mm-hmm.
People measure things by hands,
Mm-hmm.
by cubits, all the way from their elbow to their hand. They measure them in feet, not your feet on your legs.
Yeah.
No, but feet, 12 inches kind of feet. Okay.
12 inches. If you have 12 inches feet, you can use that.
Some people have 12 inches feet. I think maybe that's where it came from. I don't know.
Mm-hmm.
Okay. Now, people measure things in meters and yards. Okay. Now, in science, we have standard units of measurement. Okay.
Mm-hmm.
So, when it comes to length, they prefer meter. We prefer the metric system, which is like meters.
Uh-huh.
Okay. Is the base unit there, meters. Yeah. And you can convert that into the other, like the American style, which is this, they call it imperial system, which is feet. Okay. You can convert meters to feet, which is why also the tape measure has both feet and meters on it. Okay. And the little line, smaller lines go into smaller pieces of that, like inches or centimeters.
Or millimeters.
Yeah. So in our instructions, the first thing we're going to figure out is how fast it's moving. So we're going to set it up at a particular height. We're going to measure that. Okay. And we're going to set up our launcher. And we're going to drop the ball. And we need a couple of pieces of information. So we already know we're going to decide the height. Okay. And then we need to measure the distance. Okay. And with that, we can figure out all the rest of the information. How fast it's going. Excuse me. Stop leaning like that. Come here and look. Here are kinematics equations.
Huh?
Kinematics equations. Can you say that?
Kinematic formulas or equations?
Yes. Okay. See the equals?
Yeah.
All right. What these do is if you have 3 pieces of information, you can figure out the other, the fourth one. Okay. So, for example, here is velocity. That's sort of like saying how fast something is going. Okay. But it also says what direction it's going. Maybe it's going forward or backward.
Yeah.
Okay. So if I know this one is the acceleration, this is how much it's speeding up or slowing down, and this is the time, how long it takes. So if I know, this is the one we're probably going to be using here. That was the one from the video, remember?
Yeah.
Okay. Now, in the first example, this is going to be change in y, not change in x, because we're starting with 1 to find out the other one. We want to know how fast it's going. Okay. So if we have the change in y, which is our height, we know is going to be whatever we set it to. Okay. Oh, this one, sorry. And we're going to know the vertical velocity is going to be 0. Okay. Because it's not going up or down. It's just going horizontal, like our picture. Where's our picture? When it comes off the launcher, it's only going straight. Okay, now after that, it starts coming down. That's because of gravity, okay? Now, that is a constant. It's always the same, pretty much, okay? We always just, when we do the math, we just assume it's the same. That is negative 9.8 approximately meters per second, okay? So for every second that it's falling faster and faster by another 9.8 meters per second. So it's actually 9.8 meters per second every second per second. Okay. So as it falls,
Mm-hmm.
it's falling faster and faster and faster and faster and faster until something happens, like it hits the ground. Okay?
Okay.
Now, we're going to set this up in a little bit, but basically we're going to know what this is. And we're going to know, oh, sorry. Please stop bumping into the camera there. All right, so we're going to know what this is. We know this is 0. What's 0 times anything?
0.
Yep, so this part will end up being 0. And then we're going to multiply 1/2 by our negative 9.8.
Mm-hmm.
And the one thing we're missing is this t. We don't know what t is, but we knew what everything else is. So we can use math to figure out what the time was. Then after we know the time, we can plug this in for the x-axis, change in x. So if you see here, let's go back to our instructions. First, we want to find the speed. And then, where is it here? Then we're going to figure out the distance, okay? Now, we already know the distance from the first height, okay? But we're going to do this experiment at different heights.
Height? Okay.
Look here. We're going to move our launcher up and down, okay? And once we know how fast this thing is coming out of here, we can predict, we can do math, and I can say before I even launch the ball where it's going to land. Isn't that cool?
Yeah.
So let's say I'm going to shoot a big cannon.
Cool.
Okay? Let's say I'm going to shoot a cannon.
Yeah.
And I want to make sure it hits the pirate ship that's coming to attack us. Okay? Wouldn't it be good to know if it's going to hit it before I even shoot the ball?
Yeah.
Yeah, so...
Yeah.
So, once we know the speed of the ball for our launcher that we're going to make, and our launcher stand that we're going to make, and every other setup we're going to do to record the data, like we're going to put the paper, then we can say, where is it going to land? No matter how high I put it, if I have the launcher on the, just above the ground, maybe it's 1 foot off the ground, 2 feet off the ground, 3 feet off the ground, just up to your head. Okay, but we're not going to do feet. Okay, we're going to measure it in meters. Okay, because that's how they like to do it in science. Okay, it's a little bit more accurate and easier to convert it into different increments. Okay?
Okay.
So let's get started.
Okay.
Okay, so we're going to use this wood to build our stand. Okay, we have the tool for the U-track for our marble launcher. And we're going to use some other things. We're going to make this stand with different spots on it where we can move the launcher to different heights. Okay?
This is a store me, so you can just use.
Yeah, hold it right there.
Okay, G.
Right there.
What about here? I can see you now. Much better. So we were having trouble placing the wood in. So we're redoing it again, but this time with a clamp, squeezer clamp.
Squeeze clamp.
Meh. It's both the same thing.
Not squeezer, squeeze clamp.
Yeah, but they're basically the same thing.
Kind of. It should work. Maybe I should do it like this. That might be better. Yeah. Oh yeah, that's what we needed.
What? Why?
Clamp always helps the job get done. We probably really should have put 2 screws in there, but 1 should be enough. All right, we're gonna do the same thing again. Okay, go ahead and stop the video. Oh, how are you gonna hold it steady? You got it straight? Yeah. It needs to go up a little bit. Look at the thing. Yeah. Make sure you keep it straight, just like that. Oh, let me help you.
I didn't know I just.
Can you see me?
Yeah.
Okay, so we've constructed our tower, our stand for holding our marble launcher, projectile launcher. So basically what I did is I drilled 2 holes here, so that way we can screw this thing in. But there is actually one problem I found. One, I need to make sure that this thing on each level is not getting twisted one way or the other, because that's going to affect where it's going to land. If it's obviously pointing left or right, it will go more left or right. So I'm doing my best to measure away from the board, because the board, I will set this to be in a particular spot and orientation, so it should be pretty close. But the other problem that I found is that my drill, I was going to drill the next holes for each one, but the problem is the drill doesn't fit very good in here. So I'm going to try to drill it at an angle and see if I can work with that. If not, then we're just going to have to test everything from from the top to the bottom and remove 1 block at a time as we go. So we'll see how that happens. All right, you can stop the video. Okay, so we have our apparatus set up. We have our assistant ready to launch the ball. Now first I'll point out we have already set up 5 different heights along this board. The top of the platform that the launcher will rest on at each height is every 25 centimeters. So I believe the height of the ramp is 4 centimeters, so it should be 29 centimeters, and then 54 centimeters, and so on and so forth. I had to reset the support so that way we could measure from the floor directly to where this thing lands. So I marked right here. This is exactly a 1/2 inch off of the main vertical support, and I've also made marks 1/2 inch off. So actually I need to adjust this. I need to adjust that so that it's at the center. So this is actually this mark is the left edge. Same distance from this inner edge to the 2x4 is that mark there. So I need to actually account for where the center of this thing is. It should be, somewhere right about there. But anyway, I'll measure that in a moment and mark it. But yeah, let's go ahead and launch our first ball.
This is the third time. 3, 2, 1.
Okay. So I think it's going to go about there. Now we're going to get our marble. Okay, take your marble back.
Let's see where it lands.
We're going to get our handy dandy black carbon paper. What's that?
Why do you have to copy blue? Why do you have to
Oh, because that's a Blue's Clues reference, of course. I think that should work where it is. All right, go ahead and launch. Launch. Oh, don't do that. Here you go. Okay. All right.
3, 2, 1.
Okay. Let's see if it made a mark. Let's see if it made a mark on there. It did.
Where?
I don't know if the camera. Oh, yeah, the camera can see it. There it is.
Where?
That was where you dropped it by mistake over there. Don't count that one. This is where it landed right there. Okay, so we need to do like 5 of them, I'm pretty sure. So let me set this back and we'll do 5 more. Okay, so we did 5 additional launches. I wasn't sure if the paper was exactly square up against this corner here, so we did 5 additional launches. It must have been pretty close if it wasn't exactly placed that way, because if you look here, we have 6 dots and they're all very, very close together. So that's a good sign for our launcher that we're getting consistent launches. Now from here, we need to measure straight down from here to see what our height is. The ball launches from pretty much the top of the rails, but if we really wanted to get technical about it, the bottom of the ball does sit, it may be hard to pick up on camera, but the bottom of the ball does sit ever so slightly below the rails. So we may have to work that into our uncertainty. I'm not so certain about that yet, but we'll have to keep that in mind, take note of that. But we're going to measure straight down, and I'll make a mark. I'll fix this mark and make an appropriate mark there for where that is. And then we'll measure from there to here to get our change in X measurement. And that way we'll have the distance. That way we can calculate our speed. All right, so I had some issues where I was messing up with my math. I was measuring in centimeters and I forgot to convert to meters before I did my calculations, and that really messed everything up. So don't do that. You'll have a bad time. But once I figured out, the issue was I was originally getting a time of like 2 seconds, when in reality it should have been like 0.2 seconds. So originally I had 2.27. I made some further mistakes down here. It was getting really rough, but 2.27. And the way the math works out, really all I had to do was move the decimal place over to fix it. But just to be sure, I really went through everything all again. But anyway, that's the time. I ended up with a speed of just over 1 meter per second. And at my second height, which ended up being around 53 centimeters, or sorry, I think I did this wrong again. Is that right? No, it was supposed to be... Oh. Okay, so we did our first test and we got our measurements, and I did the calculations to determine the time. So at the height of 25.4 centimeters, we ended up with a time of about 0.2 seconds to hit the floor. And then that calculated out to be about just over 1 meter per second. Okay, and then By the way, I'm tired, so I made a lot of mistakes with converting between centimeters and meters. It was ridiculous. But, anyways, uh, pretty sure I got it squared away now. So, at the second height, which is 50 centimeters, okay, I came up with a predicted time that should be about a third of a second to hit the ground. And the distance should be just shy of 35 centimeters. So I measured with my tape measure from here to here. I put roughly, what's about the center of the cup and at 35 centimeters. So let's give it a shot, see if I didn't make another mistake with my math. But it should be pretty good. So here we go. Loading the ball. Oh. Well. Let's see. Let's try again without moving the cup. Okay. All right, so I went ahead and taped down the center of the sheet to about 35 centimeters. And now I'm going to record the actual distance. And it should be pretty spot on, I think. For the cup, I did miss the first shot technically because I put the center of the cup pretty much right at 34.9 centimeters. But because the cup is so high, it was like actually hitting the edge of the cup. I'll have to go back and watch the video, but I think that's what it looked like. It either hit like the inner edge or the outer edge and knocked the cup over. But the other couple shots I did, the marble actually like bounced out or like knocked the cup over. So it's basically hitting right where it should. So that's cool. Okay, go. Did it land in the cup?
Yeah.
What happened though?
It backfired.
It bounced out. Try again. Oh, got it. So, was our math pretty good?
Yeah.
As long as we did it right? Huh? What happened when we did the math wrong?
It didn't make any sense.
Yep. So it's very important to convert what properly?
What was it called again?
Units. The units of measurement need to be matching in the equation in the right spots. And we need to convert. We had to convert from what? What did we have to convert from? What were we measuring? Centimeters to what? Meters. Okay. Okay, so we put a rubber glove in the cup to stop it from bouncing, and then I also moved the cup slightly forward because the cup is tall and it was hitting the rim or the sides of the cup. So let's go try it now. Oh, misfire. Nice, again. Nice, again. Nice, again. So except for your misfire, 5 for 5 now. 6 out of 6. All right, you ready to build a rocket launcher now?
Yep.
And we'll go fight pirates?
In space? What?
Space pirates, yes. All right, let's do it. Okay, launch. Oh, it bounced out again. Try again. Let's see what happens. Oh, try again. Yes, direct hit. That's all right. Yo, it bounced out again. Try again. Try again. Hey! You sunk my battleship. Arg, matey. Oh, that's another cannonball at the space pirate. All right. Okay, we're at our 4th height. This one's going to be a little bit more difficult. But let's see how we do.
What?
Launch. Oh. Moved their cup. Try again. It's hard to see where it was landing.
I saw where it landed. It landed right here.
Right there? Yeah. Oops. Let's check our distance. Don't bump into that thing. Okay. All right, this time we got the center of the cup. And it's actually, we moved it to the left because it does look like it's pointing. We'll try that. So we're a little left of center. Go ahead. Oh, it went short that time. So there's definitely a lot more. It's definitely not quite so exact when it's further away. Go ahead. Why is the top of that bouncing so much? Go ahead, go. Launch. Let me try one.
You might have better luck than I have.
Whoops.
Mother, stay up.
Oh, man. Okay, so let's check our distance here. So we definitely... So basically we're putting the back edge of our cup at the measurement 49. So we have to go forward and left. We're definitely a little, center's like over there. So we're having to go forward and left of our prediction for it to actually hit the cup. So we'll get the carbon paper and see what kind of measurements we're coming up with. Test 5. Oh.
Daddy,
Okay, let's see your stuff.
excuse me, sorry.
Oh, again. Oops. Let's see. Oh. Yeah.